Let's go. We staan hier bij de fabriek van Dynaudio in Denemarken. Ja, wie kent het niet? Wij mogen zo naar binnen om te kijken wat voor speakers ze maken, hoe ze maken, wat voor kasten, hoe ze die kasten in elkaar zetten, wat voor units erin gaan, hoe ze R&D doen. Ja, ik hoop gewoon een complete fabriekstour natuurlijk. Collega's zijn al binnen, ik sta buiten hier, veel te laat alweer. Ik ga naar binnen en even kijken of de koffie beter was dan in het hotel vanmorgen, want dat was echt niet zo heel erg lekker. Loop maar mee!
The heart of every woofer is the magnet. Yeah? So in this area where we can walk around now, this is where the magnets are assembled. It starts all with ferrite rings, and these ferrite rings are not yet magnetized. They don't have any magnetic power. So even the magnetic power, we see that in the next machine, can be different from model to model. It can be stronger or a little bit lighter or how you want it. I said that Dynaudio started by making their own drive units. And of course, when Dynaudio started, we thought about, okay, what would be the best cone material for Dynaudio? Is it aluminium cone or metal dome? Is it woven Kevlar? Is it paper cone, coated paper, polypropylene, or whatever? So all the good materials have one big disadvantage. And that's why Dynaudio started very early to find a different material. And that was MSP. MSP material gives the best combination out of lightness, stiffness and inner damping. It's not the lightest or the stiffest or the one with the best inner or the most inner damping, but it's the best balance out of all these without one big disadvantage. This is a one-piece molded cone. There is no glue and there is no dust cap. It's made out of one piece. So in the low frequencies, this is pushing air, and when the frequencies go to the mid-range, the sound travels to the center of the cone, and it can.
So you do make a mid-range dome?
Yes,
We do.
But it's
exactly.
integrated in the...
Exactly. For most Dynaudios, it's a very large voice coil. In some models it's a bit smaller, but then it's very, very long. So why is not everyone doing big coils? It's very simple. Most coils are made out of copper. Copper wire simply gets too heavy when you make the voice coil too large or too long. So when Dynaudio started, it was again like, okay, if everyone is using copper but has to live with limitations, why don't we find another material? And that's why we have aluminium, pure aluminium. Aluminium has half the mass, half the weight of copper. So we can double the diameter and it's still not heavier. Or we can make it double as long and it's still not heavier. So this is the Special 40. You can see this slightly purple pinkish material, which is very, very rigid, but you can blow air through it. So this is a very clever material to have it exactly this place. It holds the cone very precisely in place, but it lets some air through as well. At one point, the magnet and the cone with the voice coil has to come together. And the way how mass production is working, it's just centered, the voice coil is centered in the magnet gap, like that. And in mass production, the theory is this spider suspension is a round material, the rubber is a round material, and everything that is perfect round will center automatically. And it does.
Except it doesn't.
Except it doesn't. So the way Dynaudio is doing it is very unique. We place very thin wires, 0.25 millimeter, between the magnet and the voice coil. So this is really pierced through the MSP cone. There are tiny holes in there. So the coil is centered in the magnet gap, precisely with 0.25 millimeter all around. It cannot move to one direction. It's impossible. So this is not almost centered, this is centered. Dynaudio is since the beginning using the coated dome principle, so coated soft door. The main reason is that it has a very smooth roll-on and a very smooth frequency response and a very smooth roll-off. To make a cone like that, a dome like that, it really starts with a fabric, and then the fabric is coated, and then it's in these boxes dried. To produce a Dynaudio tweeter, it takes up to 8-9 hours to make one of these tweeters. This one is not mass production, as you can imagine. As you can look around, it's not made for mass production, it's made to sound good. So again, we have a different approach from the start. It's not how cheap and how fast can we produce it. That was not the task. The task and the idea was, okay, how does it have to be to have a smooth frequency response with no ringing and a very good sound radiation matching the woofer.